Morning, everybody, and welcome to our pitching sessions. Put your headphones on because we're about to get started, and that's how you're going to be able to hear the session. Ready to go? All right, my name is Emily Johnson. I'm super excited to be here with you this morning to hear some amazing solutions on the topic of energy. We're hearing so many crazy solutions over the days of the festival, and this morning is all about the transition to a more sustainable form of energy, which is so important to transition from the business as usual as we know it right now. So you're going to be hearing a lot of amazing pitches, and we'll also have some time for Q&A with our wonderful jury who are sitting here in front of us. And there won't be a specific prize, but for the jury to know, you will get to vote on your favorite startup of the day based on a QR code you should have received. Now, I want to hand it over to the jury to introduce yourselves, so you can just say very briefly who you are, and especially what are you looking for in the pitches this morning. And you're welcome just to stay seated. You can turn around and welcome our wonderful audience, but we'll stay seated, yeah.
Okay.
Go for it.
Perfect. Everybody hear me? Hello, everybody. My name is Sevinch R. Shimo, and I'm working at Choose Paris Region. We are the economic development agency of the Paris Region government. And our mission is to help foreign companies to establish their business here in Paris Region. So why we are here and why clean tech and energy is very important for us is because in Paris Region we have backed ambitious projects to make our city greener. And we promote mobility, we promote energy efficiency, we promote circular economy. So I'm really delighted to hear all these pitches.
Thank you so much.
Hi, everyone. So my name is Oriana Comte. I'm part of the investment team of Quadia. And I'm very happy to be here. So Quadia is an impact investment company based in Geneva. And we are investing in companies that are transforming their value chains towards a more regenerative economy. And of course, energy is part of the sectors that we are focusing on because using more wisely energy and reducing our energy consumption is key in this transition. Thank you, everyone, and I'm very happy to be here.
Thank you. Happy to have you here.
Hi, thank you. Hi, I'm Sophie. I'm working at the German Energy Agency as an expert for startups and ecosystems. I'm in the team for Startup Energy Transition, and we run an annual startup award for energy and mobility startups globally. And yeah, I'm very happy to see former Z100 or former winners and finalists who took part in our competition here at Change Now on stage or even at the exhibition area. And we are very happy, and we always look for startups, for innovations to support or to get visibility on. This is why we are here at the Expo at Change Now.
Thank you very much.
Good morning, everybody. My name is Fabian Can. I'm the CEO of Lily Capital. And Lily Capital is based in Switzerland with a global focus on early stage companies. And energy is one topic which is our heart, but also we invest in education and reducing hunger topics. And we just go for companies we like, and we are not too restrictive on the fields we invest.
Mm-hmm. Fantastic, thank you so much. And big round of applause to our jury. Now, we're getting to the real heart of what this session is all about, and that is we're going to hear from different solutions on the topic of energy. They only have 3 minutes to pitch. It's not a lot amount of time to really get the essence of their solution. And we are going to be strict with the time because we have a tightly packed schedule, but we will have time for Q&A with the jury afterwards. So please make some noise because this is really like a scary thing to get up and pitch your solution. So make them feel really, really welcome, guys. You. And first up this morning, we have Koolboks, who are making eco-friendly refrigeration affordable and accessible to all. So welcome to the stage.
Thank you.
And have fun.
Very much.
Thanks, everyone. My name is Natalie Casey. I'm the Chief Business Officer at Koolboks, where we make sustainable cooling accessible to all. Last week, I met with Mama Ibadan. She's a fish trader and one of our first customers in Lagos, Nigeria. When I asked her about her Koolboks solar freezer, she thanked me and she shared with me how much this product had impacted her business and her life. She said, I can't tell you the number of times that I used to have to throw away my fish at the end of the market day because I had no place to store them. I now save money and I sell more. It is clear that this solar freezer has had a significant impact on her life and is solving a huge problem. And why is that? With a population of 1.2 billion, an estimated 770 million people in sub-Saharan Africa don't have access to energy or electricity, and only 17% have access to refrigeration. This leads to significant wastage of food, with an estimated 40% of food lost each year based on poor storage methods. While refrigerators could be a solution, affordability is an issue. And so the systems that are available generally employ older generations, and they have refrigerants that are harmful to the environment. At Koolboks, we have a solution which is cool technology. It provides 24 hours refrigeration by storing energy in the form of ice. It eliminates upfront costs, and it protects the environment with a natural refrigerant. By combining solar refrigeration with PAYGO technology, we break the barrier to accessing sustainable cooling. We offer financing to our customers, many of whom are women, and some who are accessing credit for the first time in their lives. We operate through both a B2C model in our affiliate in Nigeria, where we sell directly to end customers, as well as through a B2B model with a network of 14 countries where we have distribution partners. In 2021, we doubled our sales versus the previous year. And by 2025, we expect to record $88 million in sales. And perhaps more importantly, with a positive impact on the environment and on the customers we serve, reducing food wastage by 1.2 million metric tons, reducing CO2 emissions by 1.5 million metric tons, and empowering women, over 60,000 women entrepreneurs.
Thank you so much. Unfortunately, the gong has gone off, so we would love to hear more from you in the Q&A, but please make some noise for Koolboks. All right, well done, thank you. Straight on to the next one. We now have Boreal Light, who are working on solar water desalination. Take us away.
So, it's a great pleasure being here with you. Do I have the slide here? Hello, good morning. This is Boreal Light. We focus on hygiene drinking water dilemma in developing markets. A bucket like this and a canister like that, which is the basis of drinking water supply for many communities. And not just drinking water, irrigation water is also a challenge in many different parts. Climate change is causing salt intrusion into boreholes. And farmers that used to have for generations running on a borehole, now they have to leave and migrate because of salt intrusion into that. A bottle like this in a market like East Africa, a hygiene drinking bottle like this costs $4. Imagine for a market that does not even produce $1 or $2 per day. And then 1,000 liters of it, it costs $200. In such a market, we came up with our solution, solar water desalination system with 3 characteristics. Running just directly on solar energy, without any battery, no diesel, no grid, nothing. Being simple solution, and also being an affordable solution. You can see one of the model of the machine right in our booth. On the simplicity, A wrench and a screwdriver can do over 80% of the maintenance by a normal plumber in a village. Nothing else is needed. And on the affordability, producing 1,000 liters of hygiene drinking water from the direct ocean water by this technology would not cost more than 50 cents for 1,000 liters. On the circular economy and social business, we are committed to this platform that we provide to villagers, having the system at the heart of a village, from one side drinking water, from the other side irrigation water, from the wastewater of the machine, from the wastewater of the machine. We do algae farming, fish farming, and sanitation, the wastewater that otherwise should have been dumped. These are some of our projects. Just quickly, you can have a look. You can check our websites. All of these photos are there. The farms, the vertical farm, drip lines that are connected to our machines, the fish farms connected to the same machine. And look at the faces of the operators. None of these operators is older than 19 years old. In the remotest part of this planet, Zaytoun was 16 when she joined us, and she could run and operate the machine all on herself in the remotest island of East Africa. This is a layout of the project. You see the solar panels here, the machine is here, saline borehole here, fish farm, vertical farm, and the sanitation center. We do have complete remote monitoring of the machine. On everything of it, we can see it in Berlin. We are selling carbon credit generated by the machines. We already sold 40 carbon credit of 41 of our projects in East Africa. And this is our current focus in different markets. So it's not just Africa. We entered to Central America and also East Asia. And this is our first assembly hall out of Europe. This is Nairobi. We are doing our installation now in Africa, generating jobs inside Africa. This is our records. So we are at the scale-up level, and it's a pleasure being in Change now. Thank you.
Thank you, thank you, thank you. All right. Next up, we have Brite Hellas, who are creating an innovative solar glass for greenhouses. Welcome to the stage.
Thank you. Good morning, everybody. Hope you're doing well. So I have the pleasure today to introduce you Brite Solar, which is a Greek startup in nanomaterials and which has developed an innovative solar panel for sustainable agriculture. So the question we're trying to answer is, how can we get more food in a sustainable way? Basically, climate change leads to substantial challenges in food, energy, and water supply. Yeah, so we need more efficient and sustainable agriculture. So that's why we are happy to introduce our solution, Pain Power, an innovative solar glass technology for greenhouses and agrivoltaics. Pain Power uses Brite's patented technology to transform UV light into photosynthetically active light for better crop yields. We use also high efficiency monocrystalline solar cells to produce solar energy. And the glass transparency is adapted to the types of crops underneath. So the crops are protected from weather hazards, and rainwater can be recovered and recycled through structural gutters. So in short, Brite's Pain Power protects and allows light intake adapted to crops while generating solar energy. There is an example where it can have a dramatic potential. And of course, we are in France, we talk about wine. It concerns European vineyards, which cover an area of 3.2 million hectares, which is about the size of the whole Bourgogne region. And if only 1% of these areas, or 3 times the size of Paris, was covered with our 80% transparency modules, then, of course, the grapes crops underneath would be protected and have enough light to grow, and we could have an additional solar power capacity of 15 gigawatt peak, which is 1.1 time the solar power capacity installed already in France. We could also avoid CO2 emissions of 2.62 million tons, or the footprint of 290,000 French people. And we could have enough electricity for 5 million people and generate 1 billion euros of revenues per year. The same could be done for other fruit trees, berries, apples, peaches, etc. And this is good, of course, for sustainable farming, right? So to conclude, we are looking for clients, greenhouse developers, agrivoltaics developers, of course, investors, to help us spread the word and help us grow. Thank you very much.
Thank you, thank you. Give it up. And for those of you who are just joining us, you're here at the pitch sessions. We're hearing solutions to our energy issue. And next up, we're going to be hearing from AXSOL Engineering, creating a new negative carbon and positive energy sanitation sector. Yoo-hoo!
Hi there, everyone. My name is Cesar Narvaez, and I'm the founder of AXSOL, which is a clean tech that has developed in 5 years of R&D, research and development, the first energy positive, carbon negative wastewater treatment plant in France and probably in the world. So we started like in 2016, December to be precise, and we have run a lot of tests and information with other companies, and we finally arrived to get a good mixing of procedures that enables us to do it, and we named it Volta. This is the name of the new wastewater treatment plant. We started by looking into the industry, and we knew that there was two main problems in every wastewater treatment solution. The first one is that it requires a lot of energy, and the second one is that we release big quantities of CO2 into the atmosphere because the procedure we privilege is activated sludge. So we said, how can we do it better? What can we do? What can we introduce to make it better? So we inspired us from a problem, which is eutrophication. And we said, how about if we take eutrophication, we control it in a photobioreactor, and we create a synergetic collaboration between bacteria and microalgae to do it. So instead of pumping or insufflating air or oxygen into the sewage to treat COD, we use algae that makes photosynthesis, that treats pollution, nitrogen and phosphorus, that produces oxygen by also capturing CO2 and giving the oxygen to the bacteria to do the job. And it works quite well. So once we've done that, we have to reinvent all the procedures so that the medullary procedure of the wastewater treatment plant was microalgae and bacteria in symbiosis. So it was quite an adventure, but we've done it. And today, we need about 15 cubic meters of sewage, 250 tons of CO2 to produce 10 cubic meters of biogas. And that can go bigger and bigger. We do it in a very small scale, so we can start. And now we are implementing a bigger wastewater treatment plant in Montpellier, in the south of France. These are some ratios about what we're able to do with this new approach. And I think the most important thing to know is that this is the first time in history that we can talk about return on investment for an infrastructure like this one. Now we can say, yeah, for an investment of, I don't know, 1 million euros for an infrastructure like this one, we can recover our miss. So thank you very much, and we wanted to communicate about this new approach here in Change Now. Thanks.
Give it up for AXSOL Engineering. Thank you very much. All right, and now we're going to hear from Storelectric, infrastructure scale energy storage for affordable, reliable and resilient grids.
Thank you. My name is Mark Howitt. I'm Chief Technical Officer and co-founder of Storelectric, and this is what we're about. We're about enabling renewables to power the world affordably, reliably and resiliently. The challenge with the energy transition is that the world's power grids are moving to renewables. They are intermittent, demand is variable and baseload, and renewables don't provide grid stability. That is the very well-known aspect of storage, balancing the energy. But there is also a question of intermittency, of grid stability, because large power stations provide natural inertia which keep the grid stable. So the more intermittent generation we have, the more instability we're introducing into the system. And as you can see from this graph, this is the experience of the United Kingdom. Once you get over 16% penetration of renewable energy on the grid, your non-energy costs of running the system start to rocket. And they have rocketed by £3.5 billion, 4.5 billion euros in just 3 years since we passed the 16% threshold. And it's going up exponentially. That's the non-energy costs of running the system. So the solution is plants that deliver balancing services, ancillary services which are based on speed of response. Now these are what batteries offer. People think about storage as being about energy. Well, that's half the issue. The other half of the issue, the stability services, providing the natural inertia that keeps the grid stable. 3 years ago, in Britain, we had 1 million people blacked out because we were relying on synthetic inertia from batteries, which is not as good as the real inertia that you need from inertial plants. And we've had many near misses since then. You also need other services, such as black start, such as constraint management. And we need to deliver them at grid scale. It doesn't work if you're using distributed scale equipment because we're trying to replace hydrocarbons at a global scale. We need it to be at suitable scale and suitable duration. Having something that's going to last for an hour or two like a battery is not going to help us after sunset on a windless winter evening when you need to power the entirety of the evening peak and overnight. The batteries will be exhausted by 6 o'clock in the evening. We need something bigger and longer duration than that can be put anywhere and near to both generation and demand. And this is the only study that has ever been put out using our storage figures for compressed air energy storage. All other CAES analyses use traditional compressed air energy storage. And as you can see, the capital costs of our plants are and will always remain less than half the price of any other technology for large-scale, long-duration energy storage. Comparing it with batteries, much cheaper, much more efficient.
Unfortunately, that's all we have time for right now, but we will be having the Q&A in a little while, so you'll have a chance to share more then. Please give it up. Make some noise. All right, everybody, we have a couple more solutions, then we're going to get to the Q&A. And we would love to hear now from AXSOL, who are manufacturing energy storage solutions.
Very much.
Here's the clicker.
Thank you very much. I think we all heard of it. We need to get rid of oil and gas. And for a net zero society, the world needs battery storage solutions, hydrogen, and synthetic fuels, which is why today I want to present 3 of our projects to you. Imagine a decentralized grid. Small, highly autonomous energy cells trade energy with each other. Electricity is distributed locally. Industry is mostly taking care of its own energy needs, and your EV and mobility solution is charged within minutes. In order to protect the grid from overload and manage electricity flow, we need intelligent control algorithms and battery storage systems. Our AXSOL Energy Container Solutions combine the both of them in one modular CBAS platform for any small to large scale application. But we identified a bottleneck to it. Current lithium battery technologies won't be able to serve electromobility and stationary use cases at the same time. Even Elon said it's going to be sodium for stationary use cases in the future. And here we have SOSA, the battery for the energy revolution. For a battery to power our grid of the future, we wanted to be, first and foremost, we wanted to be safe. Second, we wanted to have high capacity, and we wanted to be truly sustainable and 100% recyclable. SOSA does all of that. We do not use any lithium, any cobalt, any mangan or rare earth, and it's the locally sourceable raw materials as well as a high level of automated production that make it even cheaper in use. Lastly, we need hydrogen and synthetic fuels for industry, transportation and mobility, which is why we want to industrialize Fraunhofer's groundbreaking solid oxide stack technology. The clue with it? The same stack can be operated to produce electricity and hydrogen. On the electrolysis side of it, we are even 30% more efficient than any competition on the market right now. And there's more to it. With solid oxide technology, we can revolutionize fuel production on a global scale. To put it in simple, we take water and CO2 out of the air, combine the two of them, and can create any higher fuel such as methanol or even carbon-neutral diesel and kerosene. Just like SOSA, we want to promote the technology on a global franchise network in order to fast-track capacity ramp-up, to create local value, and to increase national independencies all over the globe. With our unique technological positioning and expertise, we can set the foundation to create one holistic energy ecosystem from one European country only. But we cannot do it alone, so come and join our Zero E mission. Thank you very much.
Thank you very much. Please give it up. You can give it to me. All right, everybody, we've got one more round of pitch, and then we're going to have our first round of Q&A. So next up, we have Gouach, who is the first repairable battery manufacturer. Please make a warm welcome. Thank you.
Hello, everyone. So yeah, we are creating batteries dedicated to the micromobility business. So when I say micromobility, I mean the scooters, the e-bikes, all the Lime and Dot that you are seeing in the streets. We think that's a great way to decarbonize the cities. The problem is that the batteries inside those vehicles are really made in order not to be recycled. So at the moment, there is just a consumable way of having those batteries. As soon as you have one cell in a battery that has a problem, you have to completely throw out the whole battery in pyrometallurgy, or basically you burn all the battery down. The recycling is really on the chemical side. What we have seen is that when you have a battery that doesn't work anymore, there is only one or two cells inside the battery that doesn't work. So the great way would be to create an architecture of battery that enables anyone or people that know how to change them to easily change those cells. And so we have created a way to make a solderless, wireless batteries that can be repaired in less than 5 minutes, and also that can be recycled very easily. So all the cells that you see in the middle are the building blocks of all the batteries, and we are creating a circular economy of cells because we are able to test and remove them. So sorry, I'm gonna skip this. But if you are able to repair the batteries and to take away the cells and use them in other application, you reduce the carbon footprint of battery by about by 3 times in many aspects: CO2 emissions, water usage, and so. Yeah, and so here. Normally you could see what's happening on the video, but the basic idea is that you can remove those plates and have access to the bare material. So instead of just throwing everything away, you just replace 1 or 2 cells. That's the basic idea. Thanks a lot.
Yoo-hoo! You can keep the microphone for a moment. All right, everybody. So we've heard from 7 amazing solutions already. We're about to have the Q&A, but I don't know about you guys. It was a big day yesterday. We're back in-person event. You might be feeling a little bit tired this morning, and we're at the energy session. So I want to invite you to stand up for a moment, just maybe move around a little bit, and we're going to make a huge amount of noise for these amazing 7 solutions we just heard. They are dedicating their time, their own energy to make our world a better place. As they come back onto the stage, please, let's make some noise. Let's make everybody want to come to our session. Yoo-hoo! Woo-hoo-hoo-hoo! All right, you can sit back down if you'd like. Thanks for standing up. Now, you all need to come into the middle, so we're in between these 2 screens. And the way it will work now is we'll have Q&A with our jury. We'd love to hear from every jury member. We'd love to ideally have a question for every solution. We have 15 minutes. So I will hand it over to you. And you have a question to start us off? As you have the microphone, go ahead.
Thank you for all the pitches. My first question is for Gouach. Just to understand better, do you already produce your batteries, and do you already have clients, and how developed are you?
Yeah, we already have clients, so we are operating about 1,000 batteries at the moment, mostly in France. Our main clients at the moment are the free floating economy because they are big fleets that we can manage. So we produce batteries for them. All our batteries are connected, so this way we can monitor all the different stages of usage of the cells inside the batteries. And as soon as we see a problem, we exchange the cells. So we have created a small demonstrator factory where we can test all the cells and do the swaps.
Thank you very much, Gouach. Yes, it's very important to make circular economy for the battery, and mainly in Paris region because we have a lot of bikes and trottinettes and electrical vehicles, so this is a huge concern. I don't have a question for you, but I was very interested in Storelectric. It was very short, and I really wanted to know, I agree with you, renewable energy needs stability. The maturity of where are you currently in your activity in UK? I mean, did you already establish your technology in UK, and how you plan to expand globally?
There are 2 plants in existence in the world, one in Germany, one in America, compressed air energy storage. Our technology is a simplification of those, which have been validated by Arup, Costain, Fortum, Mott MacDonald, Siemens, Mitsubishi, both of who, the last 2 say that they can build it with off-catalogue equipment. And Mitsubishi even offer EPC guarantees for a first of a kind. The technical risk is that low. Up till now, all the investors have wanted to invest in the second plant, so we haven't yet got a first one of our particular technology. But the first one will be commercially profitable and is the next reasonable step according to the European Union. So we are wanting to build that first plant which will be commercially profitable. Technical risk is so low that you can have an EPC guarantee on it.
And next question, what will be the cost operation of a plant?
For the first 40 megawatt, 200 megawatt hour plant, it's about £50 million, 60 million euros.
Okay.
Capital cost, and less than a third of the levelized cost of storage of batteries.
Thank
you. Thanks. I have a question for Brite Solar. I actually have 2 questions. I hope that's okay. First of all, I was wondering about your actual business model. Do you sell the plants or do you operate them yourselves? And if so, how is your relationship with the landowner or the farmer?
Yeah, for this, in fact, we today sell some panels to developers, to greenhouse makers, and in fact, these panels are coming today from China. But we are preparing for our own plant to be built probably in Greece. We don't know yet if it will be in Greece or in Germany, but it's underway, and we hope that from summer next year, we'll be able to produce these panels in Europe with the maximum European components, of course, and with the special coating that we are developing.
Thanks. And maybe one more question. And you mentioned somehow or somewhere that the rainwater will be recycled. Are you also planning, or do you already plan on maybe integrated watering systems, or maybe I just didn't?
Yeah, this is something that has to be done with the agrivoltaics structure maker or greenhouse makers.
Okay, perfect. Thank you.
First of all, thank you very much for all the pitches. You did a great job. My question goes to Koolboks, and by cutting the technology, how much cheaper are you, or what's the metrics on in comparison to the battery-based competitors?
So the way that we provide access to sustainable refrigeration is by eliminating the upfront costs. What makes it less costly versus the alternative is that oftentimes our customers are supplementing the lack of electricity with diesel fuel. And so really the savings that they're seeing immediately is that they no longer have to power a generator in order to keep their refrigeration systems with continuous refrigeration. So we see that there's sort of a switch between the payments that they would be making with the Koolboks freezer. They would actually be spending less money on a monthly basis than versus what they would be paying on diesel. And that's approximately 40% savings over a 2-year period.
Okay, good, thank you.
Good morning, congratulations for the speeches. I have a question for you for AXSOL. You mentioned that for your wastewater treatment plants it would not be longer a cost, but let's say the business model would be profitable, but many of those wastewater treatment plants already produce biogas across the world. So what is so special and what is the source of revenues you have in mind?
Yeah, for sure, very good question. Actually, from one kind of size, it's 20,000 people. It's usual to have a digester unit, next site. But the problem is that since activated sludge is a technology that is used for treating water, for degrading carbon, the organic matter, then you always need more energy than you recover by the digestion. So in our approach, as we change the technology of treating the pollution, we use algae and bacteria at the same time, we reduce enormously the amount or the OPEX, the energy expenditure for treating and reusing the water at the end, for treating the pollution. So the energetic gap this time is positive because the anaerobic digestion part of the wastewater treatment plant produces more energy than it's needed for treating the water at the first stage. That's why it's different, it's a shift. Yeah.
Thank you. I have another question for Boreal Light. You have stationary water plants. I think about maybe providing drinking water to villages. Women, mostly women, I think, still have to carry it to their houses, to the villages. Do you plan on somehow getting better access or delivering water also?
We can just answer part of the challenge, not all the challenge around the world. But to answer this specific challenge of the last mile water delivery, we are doing 2 things extra. One is investing in electric cargo bike, specially designed for water delivery. So this is what we are already added in few of our applications, plus short mile pipelines. So up to 1.5 kilometer diameters around our stations. We have done it so far in 10 of our water kiosks, that is 4 pipes from the water kiosk going for 1.5 kilometer and then having a station there. But the locals themselves, they are finding the better solutions. They come with their own bikes, they come with their own motorbikes, they come with their donkeys. So we do it as part of our service, but we are not responsible for it because the locals, again, they have the means and the talents and everything to handle it. The challenge was water that we solved.
I have one question for AXSOL. You said that you created the post-lithium battery. And you talked, if I'm not wrong, about local raw materials. What is it exactly? And not sure to understand well.
Yeah, no problem. So the thing is, the Fraunhofer Society actually took 10 years to further develop the technology. The technology already exists since somewhere in the 80s. And they optimized it towards, let's say, ecologility and economics. So what they did, they optimized the production process to such a way that we can lower the production cost of around let's say 80% towards the base technology. And the raw materials that we're using is only water, salt, nickel, carbon, alumina, and a little bit of magic, as the guys from Fraunhofer say it. So it's available resources all over the world, which then creates a complete ecosystem around the franchise factories that are built up all over the globe. We need to create let's say, a family around that, to have consortia all over the world in order to ramp up the production capacity as efficiently and quickly as we need it to have. And that's the reason. Oh, that's the thing behind it.
Okay, thanks. Do you have another question? I have a last one for AXSOL Engineering. I wanted to understand if it can be run at a larger scale, because if I understood well, for now it's a small scale setup. So
Yeah, for sure. What we're doing right now is trying to get a bigger installation. We started with a 100 people unit. We're building now a 500 people unit, and closer. Yeah, thanks. So we already built the 100 people unit. We're building now the 500 people unit, and the 500 people unit is going to be replicable. It's going to be a module that's going to multiply in terms of the size of the wastewater treatment plant we wanna build. Yeah.
I have one more question for Koolboks. How do you take care according maintenance in the different areas? And is one solar panel or one solar panels for one Koolboks, or are a plant also powering several Koolbokses at the same time?
Great, thank you for the question. So as I mentioned, we have two business models. For our B2B business model, we work with last mile distributors of solar home systems. When we onboard a new distributor, then we train them on our systems, and they are then able to provide installation and maintenance for our products in their respective countries. Where we have a B2C model, which is currently in Nigeria, and we also have plans to open an office in Kenya later this year, we have a local team of solar engineers who are responsible for installation, maintenance, customer service, after sales. So we have a team of 50 employees currently in Nigeria, and we're growing as we continue to grow the business. About the number of solar panels, we offer different sizes, and so depending on the size of the freezer, depending on what it's being used for and the amount of energy that would be required, then there are different configurations that would require one or more solar panels.
Thank you.
I have a question for you, Mark. Compressed air energy storage, that you rightly pointed out, has been there since the 70s, if I'm not mistaken, with very low efficiency due to heat and, let's say, losses in the process. What is so special in your technology which would, let's say, make us dream that this technology will be efficient?
We've got two basic technologies. One is diabatic, which basically wastes the heat of compression and burns gas during expansion. And the other one is adiabatic, which stores the heat of compression and puts it back in during expansion. We've cracked both processes with slight changes of processes that actually simplify the two existing plants rather than complicate them. It means that we can use off-the-shelf equipment rather than bespoke equipment. The diabatic one simplifies the Macintosh Alabama one, which moves the round-trip efficiency from 50% up to the low 60%, and is retrofittable to suitably located existing power stations. The adiabatic one takes the heat of compression, puts it back in during expansion, burns no gas at all. And that increases the efficiency of the Huntorf one, simplifying it, from 42% up to 70% round-trip efficient, grid-to-grid lifetime average, which is much more efficient than you can get from a grid-connected battery. And by the way, the diabatic one is also dual fuel. It can work on methane, hydrogen, or any mix of the two, so it will decarbonize as the grid decarbonizes. The adiabatic one is zero carbon from day one.
We are coming to the end of our Q&A. We have time for one more quick question.
Okay, I'm sorry. I'm just wondering by Storelectric about the availability of salt caverns. Do you have problems with that, or do you have good access?
All salt caverns are man-made. Very, very simple. You find a geological layer of salt, which are very plentiful. You drill a hole, pump in water, dissolve the rock, pump out the brine, and what's left is a cavern, and it's naturally airtight. So it is very simple to make these things around the world. You can make them for compressed air. We can also make them for hydrogen as well, hydrogen storage at large scale and high pressures. So there is no great restriction for a long time. When we've got some plants up and running, we'll have the resources to develop other geologies like aquifers, especially saline aquifers that are not drinkable, so that we can store much larger volumes and use areas that don't have salt geology.
So you're also planning about doing or crafting the salt caverns on your own and not using shut-down ones only?
We would use shut-down ones if they're available, especially for the small plants. For the large plants, we assume that we're making our own.
Okay, thank you.
All right, that's unfortunately all we have time for right now. Please make a huge amount of noise for these amazing 7 solutions. Thank you all so much. And you can give this to me, and you're welcome to move on. Now, of course, when we're dealing with something as complex as our energy systems, it's not about finding the one solution, but we need many different solutions to be able to handle this energy transition. Lucky for you, we've got 7 more of them coming up right now. So we're about to hear from our next solution, and that is Ecoligo, providing solar projects to emerging markets. Thank you.
Hi, I'm Claudia, Senior Project Manager of Fundraising at Ecoligo, and I don't have a clicker. I'd like to present our energy as a service solution to you today. So we all know that for tackling the climate crisis, we have to stop talking and start acting. And that's what we do at Ecoligo. We, since our foundation, achieved the incredible goal of saving 1 million tons of CO2 that will never enter into Earth's atmosphere. And with our global presence, we are perfectly positioned to bring this to 140 million tons of CO2 by 2031. And here's how we do it. This is Fair Freak, a chocolate manufacturer in Ghana that you might have heard of. And just like many of our commercial and industrial clients, they are suffering from the high cost of power of the electricity coming from the grid. And since they became our customer, they now benefit from cheaper and cleaner electricity. Because we enabled to have the installation of a rooftop solar system at the factory, and we do this with our fully financed one-stop shop where the client pays us a monthly fee and we take care of all the rest. We take care of the whole value chain. We first of all finance the project through our crowd investing platform in Germany. We then ensure qualified engineering and the sustainable operation and maintenance of our system and insurance as well, whereby all the manual work is done by local partners, qualified partners that we enter into long-term relationships with. So besides being a hassle-free solution for our clients, they also have monetary savings from day one from the operating system compared to what they would pay to the grid. This is our growth that we have achieved in the past. So since the end until the end of last year, we installed 19 megawatts, and we already contracted more than 50 megawatts in signed projects. Our annual recurring revenue grew very strongly, and we're happy that this growth continue in this way. And this is the goal I was talking about. So by 2031, we want to have contracts signed that will save 143 million tons of CO2. And if you were wondering where we do this, we are focused on emerging markets. We started off in Kenya and Ghana in sub-Saharan Africa, and we are global around the world. We have offices in the countries that we're active in. And if you would like to become part of our mission, here's how you can. As a retail investor, you can invest into our CO2 offsetting projects on our crowd investing platform. As an institutional investor, we have asset portfolios that you can invest in. We're always looking for project finance for our larger projects. And of course, you can invest into our company growth, into equity. So meet us at the accelerator area. We have a booth over there, and happy to talk to you further.
Really good. All right, right on to the next one with our tight round of pitches, and we have Ecotone Renewables. And here you go.
Hello, my name is Sasha, and I'm the co-founder of Ecotone Renewables, which is closing the food loop. Food waste is an incredibly expensive problem. Every year, $1.2 trillion of food globally is wasted annually. That's the equivalent of solving world hunger 180 times. And so my friends and I thought that we could help solve this problem. We interviewed over 100 people in the restaurant, event, and agricultural industry and found 87% wanted more sustainable waste recycling options, 81% were paying waste to go into the landfill, and 91% of farmers were utilizing fertilizer based off of ease of use, cost, and quality. That's why we developed our patent-pending Seahorse system, which takes otherwise wasted nutrients and revenue and places it back into the food system. It fits neatly into a shipping container and can produce $40,000 in revenue of fertilizer byproduct, along with 7,000 kilowatt hours of electricity that we use to power the system. So we have no waste byproduct, and this is a completely standalone system. We analyzed the market in the United States and found for waste removal and fertilizer that it's a $27 billion market, and within our region, that's $1 billion. We are also seeking trends. Fertilizer prices are increasing. Last year, 84%, and this year it's expected to go up even more. We've been operating in Pittsburgh for 2 years, and this month we just launched our second system. We test all of our fertilizer against leading competitors, and I can tell you that it's the best that you can find. Also, this year we've produced $40,000 in revenue from both our fertilizer sales and also from waste hauling. We're currently available in 12 retail stores across 20 states, and we're hoping to release 300 of our newly automated systems in the next 5 years. We can also see that there are a lot of trends in waste removal and fertilizer as well, upwards of 230 in equity and $100 million potential in exit valuations. We have an incredibly diverse minority-led team with people from a variety of different educational and industry backgrounds, and we all have a love for sustainable food systems. Right now, we're seeking to end our fundraising for this summer. We're currently at $150,000 through minority-funded venture capitals, and we have 2 contracts to release 2 of our newly automated systems by the end of the year, so we're seeking robust lead investors. Thank you so much. We're Ecotone Renewables, and through sustainability, reliability, and growth, we're closing the food loop.
Oh yeah, thank you so much. You can give it to the next one. Perfect. All right, next up we have KRAFTBLOCK, who have a net zero heat system replacing fossil fuels.
Yeah, good morning, ladies and gentlemen. Let's speak about something different. Let's do something different. I just want you to take a moment. Just close your eyes, have a deep breath, and try to feel and experience your environment. So really, can you feel it? Probably you do, but you're not aware of it. It's warm, it's heat in here, it's thermal energy, it's needed by mankind. But did you know that more than 50% of the energy demand of an industrialized nation is based on thermal energy, on heat? And this heat is generated by burning fossil fuels. In other words, if we do not decarbonize heat, we will lose our race against climate change. And exactly for this problem, KRAFTBLOCK delivered a solution, a multifunctional energy storage system that's able to decarbonize different industries. The core of it is a high-performance thermal storage system that can be charged by waste heat resources from steel, glass or ceramics industry, but even better, using renewable energies, buffering fluctuating energies and delivering 24/7 to the customer side. Here you can see some of our main USPs. Take a look at the capacity. It's quite amazing. One of our competitors stores 1.5 megawatt hour thermal energy in a 20-foot container. 20-foot container is roughly the size of a mini tiny house. We can store 10 times more in the same size. So having those technical advantages, but also superior economics, we already entered a $130 trillion market for decarbonization efforts. On this slide you can see, I hope you can see, our first net zero heat system. It will be deployed next year in the food industry. There we replace a 22 megawatt gas-fired steam boiler against a combination of green electricity, power to heat system to convert electricity to heat, and our storage system to deliver 24/7 carbon dioxide-free heat to the customer itself. So decarbonization in just one step, in one glance. We have gone a long way so far. So a lot of R&D, prototypes, pilots in different industries. We have started commercializing the systems, also with large-scale systems. And this could not be done without our outstanding team of really 20 very, very good and experienced engineers. The team was founded by my co-founder Suzanne and me. Suzanne owns a PhD in economics and risk management. And I myself, I'm Martin, CEO of the company. I have a PhD in chemistry and nanotechnology. At the moment, we are start scaling and growth. So, ladies and gentlemen, you could read this text for conclusion, but forget it. Just try to remember my introduction to this pitch. Try to be aware that heat is essential for mankind. Try to be aware that we have to decarbonize it and join us on our journey to a net zero heat future. Thank you very much.
Thank you. Let's make some heat and some noise. All right. Next up, we have got Allume Energy, who are enabling apartments to share solar energy.
Thanks. Cool. Hi, everyone. My name is Jack Taylor, and I'm the General Manager of Europe for Allume Energy. And today I'm going to talk to you about how we're unlocking solar for apartments. So we all know the benefits of solar: reduced electricity bills and carbon footprints for the occupants inside of a home. But apartments have been missing out with essentially no solution to apartment solar. The only real way you can do it is by having an individual solar system for each individual apartment. And that quickly becomes infeasible, which is why the vast majority of apartments aren't connected to solar. We didn't think that was right, so we created the SolShare. And it is the world's only hardware for connecting multiple apartments to a single rooftop solar system. We have over 100 systems installed across the world, connected over 1,000 apartments to rooftop solar. 28 employees based in Europe, USA, and Australia. It's also an award-winning technology, which we're really proud of. How does it work? Essentially, it connects multiple apartments to a single rooftop solar system. That's it. It's super straightforward, it's super simple to understand, and it solves a massive problem. It connects behind the meter. It's not a microgrid. There's not complicated blockchain or anything like that. It is a simple solution to connect apartments to solar. Sorry, I feel like I'm repeating myself quite a lot here. It's proven across multiple continents. So we have installations in Australia, in the US, now in Europe as well. And essentially, it reduces the carbon footprint and electricity bills for apartment residents. And if you're looking at EPC ratings of apartment, it also contributes to that as well. And it does so at an affordable cost. So typically, a system will come in at some price between 2,000 and 4,000 euros per flat. And that's for everything. It's for the panels, the inverter, the SolShare, everything, labor, everything you need. So it's actually an affordable system as well. So how do we operate? Well, with a global problem and a solution to solve that, we need a way to expand quickly. So traditional solar installers can use our technology and they can install the system. So we train up local installers of how to design and install the system. And then we focus our efforts on generating lead and business development through our end user customers, which are mainly property developers, social housing providers, and energy retailers. So the market in Europe is 35 billion euros, and essentially an untapped market. Our growth, we've grown in the last 24 months at 2 times every single quarter. We've got 2 million euros at annualized revenue, and we've got over 10 million euros worth of projects in the pipeline, which are actually improved. That's not sort of like fairy tale projects, that's actually approved projects. From a funding perspective, I've got 15 seconds. We've just completed our Series A at 9.3 million euros, and we'll be looking for our Series B in about 12 months' time to expand further. And we're also looking for employees, great staff to join our team so we can expand even further. Thank you very much.
Thank you, thank you, thank you. All right, so amazing to hear all of these solutions to problems that we didn't even realize we had until we hear about it, and then you're like, yes, I do need solar for my apartment. This is amazing. Next up, we're going to hear from Leviathan Dynamics, cooling and heating using water.
Hi everyone, my name is Naufel Menadi and I'm CEO of Leviathan Dynamics. As you can see in this picture, the heat vac systems are existing since some years. Thank you. And in 2020, 1.5 billion of these HVACs has been installed. The projection of this is going to be increase in the volume of installation of these HVACs. We're expecting to have 4.5 billion, even a little bit more. But this is bad news if we don't challenge the status quo. Why? Because there are 2 blind spots. The first one is going to be concerning the electricity that is going to be consumed. And the second is this villain in the story, which is, I call it the FZilla. FZilla is going to be heating the earth, and it's related to the fluor gases that are used in the compressors of these HVACs. The global warming potential of these gases compared to the CO2. CO2 is the one greenhouse gases the most existing. It's 76% of the gas greenhouses, but the power of heating of these fluor gases is thousands more than the CO2. So we at Leviathan Dynamics, we believe that we need to be getting to the basics. Basics is going to be thermodynamics systems. The innovation that we brought is to be just thinking about how can we make this cycle perform better in a different way using a compressor that is going to be the main point to change the way we are going to be creating heating and cooling. So what we did is to be starting from the beginning. So we are designing a centrifugal compressor working with vapor of water at high speed. And we are designing the impellers, the wheels that you can see here. So we are starting from the basis, and we make a lot of calculations in order to design the best way to be performing compression. So we can do it here, as you can see, in a double stage compressor that is going to be bringing efficiency and consuming less energy in order to be reaching the target of cooling and heating. Then we are building the compressor by itself. As you can see in this picture, the size of the compressor is not that impressive. And then we are going to be including it, as you can see here in this picture, on a chiller, on a heat pump, on the machinery that is going to be giving us the best COP, the coefficient of performance, and secondly, to be having a need of less electrical energy. We are assuming to be reaching minus 30% in terms of consumption of electricity. So here what you see in this picture is the first machine that is going to be installed this summer in Guyana with Ariane Group. It's a machine that is having 20 kilowatt cooling. Thank you.
Unfortunately, that's all we have time for now, but please, warm round of applause. And there will be time shortly for more questions, so you will get a chance to finish off what you wanted to say. But we have two more solutions to hear from before we have the Q&A. And the next one is Power-Blox, who have developed a revolutionary decentralized battery system.
Thank you very much. By 2030, still 600 million people will not have access to electricity. So we will completely miss Sustainable Development Goal number 7. But what is even worse is that 40% of these people are children. They're 14 years or below, so they soon will need jobs. But without access to electricity, jobs will not be available. So, and that's what we work at Power-Blox. So let's have a look at the current solutions on the market. On the lower power range, we have the solar home systems, solar torches that provide electricity or light to a single household. But they're not really decent for small businesses. On the upper end, we have the professional mini-grid systems that are providing decent power, but they're very expensive, they're very complex, and these companies unfortunately didn't get the finances for large-scale electrification. So what we tried at Power-Blox is to bridge this solution gap between these two systems. How do we do that? We created a radical new way of electrifying such houses. So we developed the Power-Blox system and put everything in a box. The batteries, the electronics that is needed to provide 230 volt AC, and directly a solar module can be connected. And that is suitable for supplying electricity for a small business. But in difference to other systems, we can connect multiple systems together and create a so-called energy swarm. A swarm is a very fascinating system because it can be increased by adding elements, it can be shrinked, it can be divided into two, and it can be adapted to all energy needs on the ground. Where we now use this radical new approach. For example, in our project with Lifeline Fund in Uganda, where we supply electricity to small businesses in a refugee settlement. So we provide them a Power-Blox and they can lease it over 1 to 2 years till they own it. During this time, they can already use the system for their own business. For example, for electricity, for a barbershop, for phone charging services, for printing services, video halls, and a lot of others. But besides their core business, they can also supply electricity to all the houses around them. And if they're successful with their business, they can increase because they can lease another device and then supply electricity to more people around them. And we are completely sure that's the approach that is needed, that we reach this electrification of 600 million people and reaching the Sustainable Development Goal number 7 with the approach of the swarm electrification. Thank you very much.
Thank you very much. All right, we've got one solution left for the energy session this morning, and that is CarbonLOOP, the first integrated energy solution. Welcome to the stage.
Thank you. Good morning, everybody. I'm Claire Chastrus. I'm the CEO of CarbonLOOP, a French startup created in 2021. So, how to reach net zero? To reach net zero, there are two main levers. We have to reduce massively our GHG emissions, and we have to develop carbon capture solutions. Plenty of solutions exist that reduce on one side or capture on the other side. CarbonLOOP developed the first solution, the first energy solution that does it all in one. We propose a carbon negative energy to accelerate industry decarbonization. So what we do? CarbonLOOP finance, develop and operate renewable energy projects. Our production unit use biomass waste that we source at a 100-kilometer range. We reduce GHG emission by producing green heat and power or green hydrogen directly on site. At the same time, we capture the carbon absorbed by the biomass thanks to biochar, a co-product of the energy process, which is a carbon sink and a great soil amendment. We valorize this biochar in agricultural applications. Considered as a negative emission technology by IPCC, biochar can generate carbon credits with high value. On a life cycle assessment, our solution carbon capture more carbon than it emits, which results in a negative emission factor for our energy. Our unique value proposition, we offer an integrated and modular service fully financed. We help industry to meet their regulatory constraints or their corporate carbon commitments while they remain focused on their core business activities. At CarbonLOOP, we stand for a net zero industry with an environmental and social impact on territories. Thank you very much.
Thank you very much. All right, guys, we've just had 7 amazing pitches. We're about to invite them back on the stage, but please, let's create some energy. Let's make some noise. Stamp your feet, clap your hands, and please welcome back to the stage our wonderful 7 solutions. Okay, we have 15 minutes for Q&A with our jury. I'll hand the mic over, and you can pass it amongst yourselves. And I'll ask you to all come in between the 2 screens. Who would like to start this round of Q&A?
Hello, everybody. Many beautiful solutions. Thank you all for your pitches. I have a question for almost all of you. I will start with the first one, ecoligo. I was impressed, very nice results. So if I understood, is crowdfunding projects. And where are you doing this crowdfunding, in Germany or okay?
It is currently in Germany, but we plan to.
I don't hear you.
Can you hear?
Yeah.
It is currently in Germany under the German legislation, but there is a new, the EU installed a new passporting system where you can apply for a license in Europe and then offer your products EU-wide, so in all other EU countries. So next up will most probably be France, Scandinavia, where we roll out the platform. Up to now, though, we have, with our 3,700 investors, they have invested 23 million euros already since our first project that was in 2017. So we have a strong and loyal base, but for growing the portfolio and for also getting project finance for larger projects because they become bigger and bigger, we also introduced a blended finance approach where we have the crowd investors co-investing together with an institutional lender. We have that established with Oikocredit at the moment. So for bigger projects, we can have access to finance quicker and have a bigger impact fast.
But maybe a last question for you. So the solar panel in the industrial rooftop, it's very interesting, and we have to have the same system here in France as well. We're not an emerging country, but we have a lot of industrial logistics sites that are looking for that, and we have regulation that is mandatory for all the new rooftop more than 1,000 square meter. So you are focusing only in emerging countries for the installation of this rooftop, or you're planning also to come in the developed country?
Mm-hmm. Yes, so maybe a bit on our background. Our founders, they met actually in Kenya, and one of them were working for the German Development Agency, and they noticed that a lot of projects do not get realized due to the lack of finance. And that is what we're solving in those emerging markets, and we think that in the developed markets we can have our projects financed, and definitely it is very important that we continue the growth here, but we are focused on the emerging markets because of that finance gap, that through the crowd investors that get attractive returns here, they can have real good impact in the countries where we are active in and solve that finance gap there.
Well, thank you everyone. It was really interesting. I have a first question for Leviathan Dynamics. So I really think that you're working on a very key solution as fluor gases, as you explained, are booming. But when will it be ready, your technology? And in terms of pricing also, will it be something that companies will be able to buy, and maybe at the end also end users like us?
Thank you for this question. So to go to the market, we need to be going with this double-stage compressor through a pilot series. So we do have now committed contracts with cooperating industrial users for producing heat pumps. So we are going to be relying on the experience of the existing players in order to be moving them fast and cooperate with them in order to be going faster and not to be in a competition way. So we need to be going away from this competition mindset to work in cooperation in order to go faster. So this is one of the routes. So the second one is going to be going a little bit more in the increasing the sizes of our machines. As you heard, the first machine is 20 kilowatt cold. It's interesting, but we would like to go further. And producing in higher volumes is going to be key for us in order to be reducing the cost of our machines. Today we are producing in a very small scale, so almost unitary, but relying on the background that we have about understanding the supply chain, the ecosystem, in order to be going faster. This is going to be the following step in our roadmap. Roadmap 2022-23 is to be pilots, and we are open, and I'm sharing this with you. As you saw, the FZILA is alone, and we are millions. So we need to be fighting this, get rid of this rapidly, and we are open for two things. First is to have partners in order to be installing and checking the efficiency of our machines. Second is to be increasing our team. Today we are 8 people, mainly PhDs and engineers. We have an amazing team, and we would like to be growing this team in order to go faster. Thank you.
Thank you. I have a question for Ecotone. What's your business model here? Do you sell the systems or do you sell the fertilizer or maybe both? I don't know.
Yeah, we do both. So our systems are B2B, focused on communities and also restaurants and breweries. And our fertilizer is B2C. So we've been operating the fertilizer sales for the past 2 years through word of mouth marketing and have expanded that all through the country at the moment.
Thank you. And maybe one more little question. The two already operating systems you mentioned, they are fully developed systems or still in pilot phase?
The first two are in pilot phase, and we have contracts to launch our fully developed systems, 2 of them at the end of the year. That would be automated.
Okay, thank you very much.
Thank you much for all of you for your pitches. My question goes to Power-Blox. And what is the size of the grid you consider as your sweet spot? Is it just sort of one blocks, or is it a whole island, or how do you see that?
Even if we do full islands, we, for example, have electrified one island in Vanuatu, Lelepa. But we consider the sweet spot between 200 watt and 10 kilowatt in this range. If you go higher, then we probably have to develop a new product that is a bigger size, because the swarm approach can be adopted in bigger sized systems also. But currently we use in the upper range, we use conventional technology, so like solar containers, for example.
Okay, good, thank you. Perhaps as a second question, how do you solve the pre-financing of the blocks? As they are still expensive for your target countries.
Absolutely, and here you focus on something that is the most difficult part of it. We never had problem to finance our own company, so getting equity for our own company. But when we went into project financing, it get very hard because it's infrastructure investment, and that's very difficult. That's why we changed our approach from going away from financing everything, but only do this on the lease-to-own model then, and electrify like this. That was working for the solar home system industry, and we adapt that for ours also. But how we do it currently is we focus really much on partnering with NGOs. So we partner, for example, with GIZ, with UNDP, and we do all the pilot financing with them together. And then based on that, we scale up.
Thank you for the pitches. My question would go to you, to Ecotone Renewables. You did not elaborate on your technology. Are we talking about, let's say, AD factories, small AD factories, or composting?
Sorry, it's small AD factories at a community level, so shipping container sized.
Okay, and so you intend to produce biogas, then to turn into electricity or to produce RNG?
Yeah, so we scrub out the methane from the CO2 and the hydrogen, and we store that and combust it on site.
Okay, and final question. So you are depackaging food at the entrance of the, or you are buying soup from third-party suppliers?
No, so the first prototype, we had people come and donate their food waste to us. The second one is based in a brewery, so they do all of that themselves. Until now, we've had to manually process the food waste, but we have a patent pending on an ML system that will do all of that for us.
Okay, thank you very much.
Yeah.
Yes, hello. I had a question for Allume Energy. So it's definitely a big challenge for big cities like Paris, all over the world, to convert the apartments, the buildings, to solar energy. First question: do you own the solar panels, or do you manufacture them yourself? If not, is there a partnership? And then, what are the big challenges you have today to convert these buildings to solar?
Yeah, thanks for the question. So we manufacture the SolShare, which is the piece of hardware that enables the solar system to be connected to the multiple flats. So we don't have any sort of issue with what panels are used or inverters or anything like that. And that also enables us to be able to grow rapidly, because essentially a traditional solar installer, just your standard solar installer, will be able to just add it to their portfolio, include it into a standard solar system, and then install that and sell it to apartments or their normal clients. So it allows us to expand really easily into new geographies. Some of the challenges that we have, we have to work with the networks to make sure that they're happy, because essentially we're interconnecting behind the meter. But we have a very concise data pack that goes with that now. So when we enter a new geography, we meet with the networks and we sort of explain why it's safe and give all the test certification to go with that, and that allows us to enter the new geography. And then from an actual sort of sales perspective, so we focus mainly on social housing and property developers at the moment. So essentially we're meeting with a social housing provider who may have 10, 20, 30, 40,000 apartments, and really want this solution because they really want to be able to help their residents, as well as obviously gain their sustainability credentials and things like that. So we pitch the product to them, and normally they love it. And then we identify the apartments that are really suitable, and then we essentially install some or all of them, and then do it on an ongoing basis with that housing provider.
The next question is for KRAFTBLOCK. And what is your ideal customer? Like in terms of size of the installation?
So at the moment we started with industrial customers, because at that stage it's more complicated to get into the market, but we have a higher impact, which means we are targeting industries like pulp and paper industry, food industry, where we can decarbonize in a very, very fast step. But also, as I explained, the ceramics industry, steel industry and the glass industry. So industries with a high heat demand.
Okay, and in the future you want to expand that? Or?
Yes, what we are doing is we are going through different business models. At the moment we are really constructing the hardware, erecting the hardware and implementing it, also to get a good experience of the system, but the final stage will be that we have the whole service system around. So we are doing the sales, we are doing the engineering, procurement, third parties will build the hardware, integrate it, we do the commissioning, and then acting also as an energy as a service model.
Okay, thank you very much.
Welcome.
I have my next question for CarbonLoop. First question is, how's your technical stage? So is it a POC? Do you have already a pilot running, or?
Yeah, we are launching our first project now, and we hope it will be commissioned mid-23, because it's take 12 months to develop all the projects. It will be based in France, near Paris, in the Yvelines. And we have a second project that we are working on that will be a hydrogen refueling station for heavy mobility, and will be developed it around by end of 23.
Okay, thank you. And maybe a second question. You mentioned your carbon sink biochar. Am I pronouncing it right?
Yes.
Okay, perfect. Do you already have partners, potential customers? Do you plan on selling it also to the industry? What's your plans here?
Yeah, good questions, because it's the most difficult part. Because biochar, even if biochar is considered as a great negative emission technology by IPCC, as I said, biochar is very developed in North America, in North Europe, but in France it's very difficult. It's not a mature market. So yes, we have to find partners to commercialize our biochar. The ideal for us, I think the ideal, is to try to valorize the biochar around the industrial site, because we want to create a local ecosystem. It's the target, so we hope that we could do that. Biochar can be used by agricultural, horticultural, or even communities. So we hope that some partners interested in biochar came to see us.
Fantastic. We have 30 seconds left only, so very quick question.
Okay, so one small question for Allume Energy, just to understand the business model exactly in terms of financing, and also how you get money from the residents. I heard that there was 2,000 euros paid per apartment, but then is there a recurrent fee that they're paying?
So it depends where we're selling into. So if we sell the product to a social housing provider or a property developer, they will simply buy the solution and then offer the energy for free for their either buyers or residents. But we also have what we call a sleeved PPA model, where we partner with energy retailers who can install the system and offer a discounted price to the residents because they're supplying grid and the solar electricity to the residents within the building. So there's a couple of methods that we can use.
Fantastic. That's unfortunately all we have time for. You can chat to our solutions afterwards if you have more questions. I'm sure you do because there's many of them with amazing solutions. Now, please, for a last time, give a huge amount of love, energy, applause to these incredible solutions changing the world. And this actually brings us to the end of the first session for today. Thank you to our jury for your amazing questions and your presence, your energy. We'll be back in just a few minutes with our next round of pitches. It's going to be reverse pitches. We're going to be hearing from mayors sharing challenges that they face in sustainability in their cities. And then after that, we'll be hearing from Sustainable City Solutions. So you're welcome to stay. We'd love to see you later on. Have a great rest of your day. And thank you so much for being here.